Hello students, welcome back to the classroom point. In our today's class, we are going to discuss about the sum problems, and these problems usually irritate the students because in these problems very less information is available, but still they ask the calculate the composition or percentage in the reaction mixture, either about the reactants or products. Let us see some of these examples here. So here, one of the question is given as a mixture of nitrogen and hydrogen is made to react in a closed vessel to form the ammonia. The reaction ceases before either reactant has been totally consumed. So that means reaction is not completely finished. Before the complete conversion of the reactants into the products, reaction has been stopped. At this stage, 2 moles each of nitrogen, hydrogen and ammonia are present in the reaction mixture. They are asking us to calculate the number of moles of the nitrogen and hydrogen present originally. So let us solve this question. Let's write down the equation for this. The equation is nitrogen reacts with the 3 moles of hydrogen to give 2 moles of ammonia. According to the balanced equation, 1 mole of nitrogen reacts with 3 moles of hydrogen and finally produce 2 moles of ammonia. And what they are saying that after the reaction is stopped, final reaction mixture is having 2 mole each of all these components. So finally how much is present? 2 moles of nitrogen, 2 moles of hydrogen and 2 moles of ammonia are present. So here only we can get the information that see, finally 2 moles of ammonia. 2 moles of ammonia always comes from the 3 moles of hydrogen and 1 mole of nitrogen when consumed in the reaction. Here 2 moles are present. That means in the previous, how many moles of hydrogen and nitrogen consumed respectively? 3 moles and 1 mole. Finally, how much is present? 2 moles each are present. Means in addition to these, we have to add these values so that we will get the initial values. So that here, initially 3 moles are present. 3 moles plus 2 moles equals to 5 moles of hydrogen is present. And 2 plus 1 equals to 3 moles of nitrogen is present. So from this 1 mole and 3 moles converted, finally 2 moles are present. So these are the number of moles of nitrogen and hydrogen respectively present in the original reaction mixture. Let us see one more important question here. When a mixture of magnesium carbonate and calcium carbonate was heated for a long time, the weight decreased by 50%. Calculate the percentage composition of the mixture. So other information is given that magnesium carbonate and calcium carbonate along with the calcium oxide, magnesium oxide molecular mass also provided. So let us see here. Here only information available is 50% reduction. By using that we have to solve this question. So let us imagine, let the mass of mixture of the reactants is equals to 100 grams. So in the reaction mixture, initially what reactants are present? Magnesium carbonate and calcium carbonate. So let us consider, let the mass of magnesium carbonate is equals to X grams. Obviously, then calcium carbonate is equals to 100 minus X grams is present. And they said 50% of the weight is reduced. So we have to write down the equation for this. Magnesium carbonate on heating produce magnesium oxide plus carbon dioxide. Being a gas, it leaves the container. And calcium carbonate on heating produce calcium oxide plus carbon dioxide. So carbon dioxide being gas, it leaves the container. So carbon dioxide will never anything add to the mass. So that the reduction is the mass is due to the loss of the carbon dioxide. Anyhow, So now magnesium oxide, calcium oxide finally present in the reaction mixture as the products. Initial reaction mixture we have taken as the 100 grams. The mass is reduced to the 50%. That means final product's mass can be taken as the 50 grams. So let the mass of products, that means together magnesium oxide and calcium oxide, we can take as the 50 grams, and I am considering the magnesium oxide mass as some y grams, and the calcium oxide mass can become now 50 minus y grams. So from this, let us try to solve the question. Now here, what we have seen is x grams. Actually from the balanced equation, molecular mass is given 84 grams of magnesium carbonate is producing the 40 grams of magnesium oxide. Then x grams of magnesium carbonate can produce how many grams of the magnesium oxide? This mass only here we call as the y grams. So that y value, mass of magnesium oxide is equal to the cross multiplication. 40 into x divided by 84 grams. Let this one consider as the equation 1. Calcium carbonate molecular mass is 100 grams. 100 grams of calcium carbonate able to produce 56 grams of the calcium oxide. Then here 100 minus x grams of calcium carbonate can produce how many grams of the calcium oxide? This mass is nothing but the calcium oxide 50 minus y grams. So here I can write down that this one is the 50 minus y grams. So again 50 minus y grams is equals to, do the cross multiplication. So it is equals to 100 minus x into 56 divided by 100. This is the equation number 2. So substitute equation 1 in equation 2. Why? Because here we got the y value. So by substituting the y value here, we can get the x value. So the value of x is equals to 28.41 grams. Since this 28x is equals to magnesium carbonate, so mass of magnesium carbonate is equals to 28.41 grams, and this we consider for the 100 grams, so that the percentage value is equals to now 28.41 percentage. Remaining is the mass of the calcium carbonate, that is y value, sorry, 100 minus x, so mass of the calcium carbonate is equals to CaCO3 is equals to, we can take this one as the 71.59 grams, or this is equals to 71.59 percentage. So copy this and we shall solve one more question. Let us see one more question here. A mixture of cuprous oxide and cupric oxide weighing 1 gram on reduction gives 0.839 grams of the metallic copper. Calculate the weight of cupric oxide in original sample. So here two compounds are given. Let us take the solution. Cuprous oxide and cupric oxide. So here total mass of the mixture is equals to 1 gram. So total mass of cupric oxide and cuprous oxide together is equals to 1 gram. So let the mass of cupric oxide CuO, I am considering as it as x grams, because we need to calculate the weight of cupric oxide only. Then the mass of the cuprous oxide could become now 1 minus x grams. So when we see the reactions of this cupric oxide and cuprous oxide, as they said, they completely convert into the copper, metallic copper on reduction. So that here Cu2O on reduction converts into the Cu plus half mole of oxygen. Similarly, CuO cupric oxide also on heating or reduction gives copper plus half mole of the oxygen. So in these conversions, copper is conserved completely. Means copper is not changing. See, it is giving 2 moles of the copper. Here it is giving the 1 mole of the copper. So now I am making the copper is conserved. So here we shall write down that Cu2O plus CuO we can write down as 3Cu plus O2. So in this particular cuprous oxide, 2 moles of copper is present. So 2 into number of moles of Cu2O plus here 1 copper is there. So 1 into number of moles of CuO equals to, we should not consider the stoichiometric coefficients. Here only 1 copper is there. So 1 into number of moles of the copper. So 2 into here number of moles of Cu2O means weight of cuprous oxide divided by its molecular mass. Weight of cuprous oxide is 1 minus x grams. So 1 minus x divided by its molecular mass is 143 plus number of moles of cupric oxide. So weight of the cupric oxide x divided by its molecular mass 79.5 is equals to number of moles of the copper. Given mass of the copper, here they said how much copper is produced, 0.839 grams of the copper is produced. So 0.839 divided by its atomic mass is 63.5. So by solving this, we get the x value 0.55 grams. Is the mass of the cupric oxide present in the 1 gram of the mixture of the cuprous oxide and cupric oxide. Now let us see one more question here. A mixture of FeO and Fe3O4 when heated in air gains 10% in weight. What is the composition of the initial mixture? So let's write down the equation for this. Actually, the mixture, whenever the mixture of FeO and Fe3O4 is heated, both are converting to the Fe2O3 only. So that here we can write down that FeO, Fe3O4 giving Fe2O3. Now let us consider, let the mass of FeO is equals to x grams and mass of Fe3O4 is equals to y grams, then total mass of reactants is equals to x plus y grams, because mass of the reactants were not given. But what they said, 10% is increase in the mass of the reactants after they convert into the product. So the total mass. Then weight of the products is equals to x plus y, that is the weight of the reactants plus 10% is in that. That means again x plus y into 10 by 100. So you'll get the 1.1 into x plus y grams. This is the total weight of the product. In this equation, reactants completely convert into the products and balanced equation is not required for the applying of the POAC. Let us consider iron is conserved. So iron is conserved, Fe is conserved, and apply the POAC, so that here 1 mole of 1 into mole of FeO plus here 3 iron are there. 3 into number of moles of Fe3O4 is equals to, here 2 irons are there. So 2 into number of moles of Fe2O3. So FeO 1 mole, so its mass x grams and its molecular mass 72 plus 3 into Fe3O4 mass is y grams and its molecular mass is 232. That equals to 2 into number of moles of Fe2O3. So weight of Fe2O3 is equals to this much is the product. So 2 into 1.1 into x plus y divided by its molecular mass is 160. On simplification, we get x by y value as 171 divided by 29. Then let us see percentage of FeO. This one is equals to 171 divided by, because x value is 171, total value 171 plus 29 into 100, so this gives 85.5%. Percentage of Fe3O4 is equals to 29 divided by 171 plus 29 into 100, this is equals to 14.5%. So like this we can identify the composition in the original mixture. Let us see some more questions now. So the question here is 4 liters of mixture of CO and CO2 is passed over red hot coke. Volume of the resultant mixtures becomes 5.5 liters. Percentage of CO in the original mixture is. Here the thing is, both the CO and the CO2 are passing over the coke. Coke is nothing but the carbon. CO is the reducing agent. Carbon cannot take the oxygen from the CO, but carbon can take the oxygen from the CO2. So that CO2 converts into the CO. Let us see that reaction. So first of all, let's write down the data. Let the volume of CO is equals to x liters and the volume of CO2 is equals to 4 minus x liters. Out of 4 liters, now it is 4 minus x liters. Then CO on reaction with coke, no reaction. That means the volume of the CO remains as it is. And CO2, when reacts with coke, carbon, it converts into 2 moles of CO gas, carbon monoxide gas. So here x liters, whatever we are taking the carbon monoxide, that remains as it is. But here 4 minus x liters, whatever we are taking for the carbon dioxide, that converts into the 2 into 4 minus x liters. Now the total volume of the carbon monoxide is x plus 2 into 4 minus x. That means 8 minus 2x liters. So total volume of CO now is equals to x plus 2 into 4, 8 minus 2x liters. Means this value we can write down that 8 minus x liters. Finally, volume of the resultant mixture becomes 5.5 liters. That means the final gas is only having the 5.5 liters and that always belongs to the carbon monoxide in only here. Why? Because carbon dioxide is not there. Now carbon dioxide is already converted into the carbon monoxide. So that's why this value 8 minus x liters is equals to 5.5 liters. Then x value is equals to 2.5 liters. So 2.5 liters is the volume of the carbon monoxide. But they are asking percentage of the carbon monoxide in the original mixture. So percentage means this value, the value of the carbon monoxide divided by original value. How much is there? 4 liters into 100. So this is equals to 62.5 percentage. Let us see one more very important question for us. If a mixture of 100 ml of methane and ethane in the volume ratio X is to Y. The ratio is given, not exact number of how much volume of the methane and ethane is present. So methane volume belongs to the X and ethane volume belongs to the Y. Is subjected to combustion. 140 ml of CO2 is produced. If volume ratio of methane and ethane in the 100 ml of the mixture is Y is to X, reversed, then the volume of the CO2 produced in the final equation is. So let us try to attempt this one. So the total volume. So let the volume of CH4 is equals to X ml and of C2H6 is equals to Y ml. Total volume is equals to X plus Y ml, that equals to 100 ml. Means from this we can write down that Y equals to 100 minus X. Let be equation 1. Or else we can write down X equals to 100 minus Y. Now let us see here combustion reactions. CH4 on combustion, when reacts with the oxygen, it produces carbon dioxide plus 2 moles of the water. And ethane C2H6 on combustion gives the 2 moles of carbon dioxide plus 3 moles of the water. So here both carbon dioxides are in the gaseous state. So now here this is equals to 4 plus 3 is 7. So that here we can write down that 7 by 2 O2. Balancing not required, combustion reaction. Directly we can get the products here. So now here we said X ml. Means X ml of methane is producing 1 mole of methane is producing the 1 mole of carbon dioxide. X ml of methane also produces X ml of the carbon dioxide. Here ethane Y ml. See, 1 mole of the ethane is producing the 2 moles of the carbon dioxide. Then Y ml of the ethane can produce the 2 Y ml of the carbon dioxide. Now the total volume of the carbon dioxide is total volume of CO2 is equals to X plus 2Y. And here they said both of these compounds and combustion is producing how much? 140 ml of the carbon dioxide. That means X plus 2Y value is equals to 140 ml. This is equation number 2. Already we got the Y value here. Substitute the Y value here. So substitute equation 1 in equation 2. So we get here X plus 2 into Y value 100 minus X is equals to 140 ml. So now X plus 200 minus 2X equals to 140. So this is X, this is minus 2X. So 200 minus X equals to 140, X equals to 60 ml. So that Y equals to 40 ml. That means X belongs to which one? Methane. X belongs to methane, whereas Y belongs to the ethane. So this is equals to C2H6. Now what they are saying, they are reversing the ratios. So Y is to X of which one? Again 100 ml of the mixture of methane and ethane only. So now in 100 ml, ethane volume of ethane C2H6 becomes X now. See, C2H6. X volume how much? 60 ml. And volume of methane. Methane volume is Y. Y volume is how much? 40 ml. Now let us write down the equation. Methane on combustion with the oxygen, on reaction with the oxygen gives the carbon dioxide plus 2H2O. So 1 mole is giving the 1 mole. 40 ml of the methane gives the 40 ml of the carbon dioxide. Similarly, ethane, C2H6, 7 by 2 O2 giving 2 moles of CO2 and 3 moles of water. So here ethane is 60 ml. See here 1 mole is giving 2 moles. So that means 60 ml gives the 2 into 60 ml of the carbon dioxide. So 2 into 60, that means 120 ml of the carbon dioxide. So now final carbon dioxide produced in the combustion reaction is, so volume of CO2 produced is equals to 120 plus 40 is equals to 160 ml. Dear students, I hope you understand these classes, and these are all different questions from the different content. So we applied the POAC, we are applying the mole concept also, but the common thing in all these questions is we have to find out the percentage or composition of the original reactants present in the given reaction mixture. Usually they give the only one hint, so based on that we must be able to solve these questions. So if you understand my class, please do subscribe the channel and share it with your friends. Thank you one and all.